Hello everyone, I am going to walk you through how to use our Vega SEM microscope, how to load samples, how to take pictures, how to focus, and how to save those pictures that you take. When you first come into the room, it's important to check that the power to the microscope is on. There's a power switch on the front panel of this box here. There's also two PCs underneath the table, one of which, the left PC, is for the microscope and the right PC is for the EDS. You don't need to touch the EDS PC, the one on the right. You can leave that. Don't touch it. But the SEM microscope, if the power switch to the SEM is turned off on the front of the machine, then the PC will also be turned off. So make sure that the SEM is turned on, and then you can turn on the PC. Once you do, you will need to log into the computer with your UTID and password for the system, and then from there we need to open the SEM to load our samples in, pump it back down, and then we can start taking pictures. So I'm going to move the camera so we can see the computer and show you how to open the chamber and log into the software. Okay, after you log into the PC and all the power's on, you're going to have your own UT desktop, and we need to use this program, Vega3, little green diamond. So you can double F click to open the software. You're going to use the guest account. There is no password, so you can just hit OK. It's going to do some kind of checks on the microscope. Right now there are a few things that need to be fixed, but that is not something you have to worry about. Okay, just going to hit close, and it opens up the screen. Now there is quite a lot here, but initially, before we load anything, all we care about is the lower right down here. So right now our vacuum, our SEM is at vacuum, so we cannot open the chamber door. This is the inside of the chamber here. So before we do anything else, we need to vent the chamber. So you're going to go ahead and hit vent, and yes. It will go through the venting process, and you will have to do this vent 3 times. So you will hit vent, it will say venting down below, it will then say venting finished. You then repeat that 2 more times, and then you will be able to open the SEM. Okay, so we'll do vent number 2, and then we would repeat that a 3rd time to open the door. Now let's look at the chamber. Okay, once we have done our 3rd vent, we can take the chamber door and pull it open. And on the inside, we will see we have a stage. Right, the stage has positions for 7 samples, right? Each position is numbered, so 1 to 7, so you know which sample sits where. And I'm going to load one of our samples inside. When loading samples into the chamber, you want to make sure to use a pair of tweezers or wear gloves. You don't want to touch any of the chamber surfaces with bare hands. So SEM stub just fits in there nice and neat. If you want to, we have a tightening screw, a set screw for each position. So if you want to tighten down your sample, you can. Once all of your samples are loaded, we can close the door and start the microscope. So I'll load one more sample. There we go. Then we just close the door until it stops moving, and then we go back to our vent and pump, and now we pump. This pumping takes anywhere from kind of 2 to 4 minutes. So what we're looking for is we're waiting for this pressure bar to start to increase. Okay, there we go. And this will be finished in 2 to 4 minutes. So we'll come back when that is complete. Alright, once the pressure is low enough, then this bar down here will be green, so we can start the microscope up. First thing you have to set is the accelerating voltage. You set that in the top right here of the screen where it says HV. So all of the beam controls are here. So the first thing we want to set is the accelerating voltage. So you will click on HV or high voltage with this, and it brings up this window here. And from here you can type in any voltage from 0 to 30 kilovolts. We're going to use 10 for this, so I'm just going to type in 10 and hit enter. And that sets it. And then to turn the gun on, we are going to hit the HV, the high voltage button, down here. So give that a click. And once we do that, we should see an image, there we go, on the screen. So now we have an actual picture happening. This is our stage. Before you do anything else, before we make any adjustments, it's always helpful to adjust the filament heating. So if we zoom in right next to the HV button, we see adjustment. And if you're going to left click that and you want to hit auto gun heating. When you do that, it is going to reset the current to the filament to kind of start you off right at a proper voltage and proper settings so that focusing becomes a little bit easier. This takes about 45 seconds, 30 to 45 seconds. And then once it's done, we can then go on and start focusing and taking pictures. Anytime you change the accelerating voltage, the first time you change it, I would do the auto gun heating in the adjustment setting. After you've done it once, you do not need to do it again. Okay, so that's gone through. Okay, so let's walk through the software. There's a lot of stuff here, but we'll just go through it step by step. Obviously, on the left here is the image window. So this is what the microscope sees. In the top middle here, this is our infrared view of the chamber. So we can see what's happening on the inside. So here's our stage right here. The electron beam comes out of this cone here, the electron column. This is our backscattered electron detector. It's currently inserted. And our X-ray detector, this kind of pencil device here, stationary. And then off to the left, you can't see it, is our secondary electron detector. If you are ever moving the sample around physically, moving the stage, you should have this infrared window open. If on the off chance it is closed, we can reopen it with these buttons on the top right. So the little camera window reopens the infrared view. But if you're ever moving the sample, we should have this camera on just to make sure we don't hit anything. All of our sample can be moved, the stage can be moved with our stage control, right, with this guy, this panel. And if you look, we have a lot of options. We can move the stage side to side and up and down on a plane. We can raise and lower the stage with the Z height. We can rotate the stage. All right, and we can even tilt the stage if you want. All right, and you can see all of this happening in the infrared screen. And then for any of these, you can also type in a value, right? So if you want to center the stage completely, you just type in 0 for X, and then 0 for Y. And then if we want to make sure the stage is not tilted, we'll type in 0 degrees for tilt. And for that as well. So the only way you can damage the microscope is if you use the stage motion controls to hit any of the top of the stage. So if you have a tall sample, just be aware when you're raising, lowering, or tilting the stage that you do not come in contact with anything else. Obviously, image window on the left here, as I mentioned, and then all of our beam controls are over here on the right side of the screen. Right. So I'm just going to go through kind of simple adjustments for the beam. So right now we're looking at the middle of the stage. Let's find one of our samples. I put them in 2 stub positions. So to go to a specific stub position, you just click on the number in the stage control panel, so position 2. So here is one of my samples. You see we have some carbon tape and I put some powder on top, and it's on top of an aluminum stub. So to make adjustments to the image, we need the beam controls. And if we zoom in, you see we have quite a few options here. Our first is magnification. Actually, our first is scan mode. You have a few options here depending on how you want to view your sample. And I would say almost all cases you want to stick to resolution. That will give us the highest quality images at high magnifications. If you do have a very tall sample and you want a large depth of focus, you can use the depth mode. Or if you want a very wide field of view, we have field and wide field, which can be used for that. But in almost all cases, I keep it on resolution. We have our voltage. Next is our magnification. All right, so magnification is how zoomed in the image is. So the same as with voltage, if you click on magnification, it allows you to adjust it up here in the top, and you can type in a number here. So we could go to a magnification, let's say of 200x, and then hit enter. Or we have a trackball. If you move the trackball to the right, that increases the value. If you move it to the left, it decreases the value. So I'm going to scroll the trackball to the right to zoom in. Right? And then to the left will decrease it. Beneath the magnification value here is a sensitivity slider. Right now it's set on 2. So if I increase this to 5, then the trackball becomes more sensitive. And if I decrease it, it's less sensitive. So I'm going to find something I can focus on. So I'll move the stage. I'll look at this little particle right here. Real quick, when focusing, if you double left click with your mouse, you get what's called a reduced scan window. So the beam only refreshes in this window. So it is very quick refresh rate, which means it's a lot easier to focus. If you left click and drag, you can move this window around. If you right click and drag, you can change its size. So now if I adjust magnification again, it now only magnifies this part of the screen. Okay. Next to magnification is view field. Right beneath it, view field is just another way to say magnification. It is the width of the image window on the system. So it's another way to just say how wide the image is. Beneath view field is the speed button. So speed controls the scanning rate of the beam. So if I double left click to get rid of this, we see right now the beam is actually scanning very quickly. So if I move the sample, the image refreshes very fast. The problem is this fast scan speed gives us quite a bit of noise in our image. So what speed control does is it slows the beam scan. So if I increase the speed number, the scan speed slows down. And you'll see it's out of focus still, but our resolution improves. We lose noise because our beam scans slower. So if you're taking images, generally you want a slower scan speed. If you're moving the sample, you want a faster scan speed. You can also control the scan speed by rotating the mouse wheel up and down. So up increases the scan speed, and down decreases the scan speed. Beneath speed is WD, or working distance. That is the focal length of the sample of the focal length of the electron beam. So it is our main focus knob. So I'm going to click on WD, and again you can type in a number here at the top right, or you can use the trackball. I'm going to use the trackball. I'm going to decrease WD. And we'll see that actually made it worse, so I will increase it. And as we increase it, you see our image now becomes much better in focus. And again, this is a fast scan speed. If we slow the scan speed down, you see we can get much better resolution images. Okay. While we're here, if you right click on the image, you have the option of auto WD, auto speed, also auto brightness contrast. I use this quite a bit. So if you right click and then left click this, it sets the brightness and contrast for you to try to remove the extreme pixels, or we can just try auto WD, and that's kind of an auto focus. Auto brightness contrast is also right here. Okay. Right now our sample is quite far away from the gun. The general rule for imaging in the SEM is you want to be close to the top of the column. So I'm going to use my stage controls here, and I'm going to raise the sample stage. So I'm going to select Z, and I'll type in 20 millimeters and hit enter. So that raises the stage up. There's a stop button here on the stage control that will pause all motion in case you're worried about hitting something, but we're okay. So now our sample is higher up, so we need to decrease our working distance because our sample is now closer. So I'll select WD again, and I'll use the trackball to decrease working distance until we are in focus again. And I'll double left click, try to improve it a little bit more. There we go. And then I'll right click and do auto brightness contrast. Okay, that's okay. So beneath WD on the right is depth of focus. That is the Z focal length of the image. We can't adjust that directly, so that's just kind of a fun label that is on there for us to know. Beneath WD is the stigmators. So the stigmators. Stigmators are a secondary focus knob that you have. So working distance controls the focal length of the electron beam. Stigmators control the shape of the electron beam on the sample surface. Right? Because the beam is controlled by electromagnets, over time it can happen where the beam becomes non-circular. And in that case, when you change the working distance, if the stigmators are misaligned, when you adjust the working distance, the image will stretch. So as I change the working distance, you can see if I go too much, the image stretches in kind of the upper left to the lower right. If I go working distance the other way, you can see it stretches the lower left to the upper right. So the stretching that you see is a sign that your stigmators are misaligned. So if you're changing the working distance and you see stretching, you adjust the working distance to try to get a close middle as best you can. All right, I'll go ahead and zoom in. Okay. I'll adjust my working distance. So there's our stretching. So we get a happy middle, then we adjust the stigmators. And now the stigmators, you'll see now there are two values here. There is an X value and a Y value because the stigmators are an X and a Y magnet that surround the beam. So if you select stigmators, use the trackball. Going left and right will adjust the first value, the X value. And going up and down on the trackball will adjust the Y value. So I'm going to go left and right first to try to improve the focus. So going to the right makes it worse. I'll go back to the left. Okay, that's much better. Now it's getting worse again. So go till it's right there. And now I'll adjust the up and down, the vertical, and try to improve my focus there. So there we go. Once our stigmators are pretty well aligned, if we go back to working distance, so I'll select WD and adjust my focus, we now see We get uniform blurring in all directions, not as much, no stretching. So that means our stigmators are aligned. Okay. The next two settings on the right are image shift and image rotation. These are both digital image manipulation. So image shift, if you click on that, it just allows you to digitally move the image a bit. So without physically moving your sample, if you select image shift and use the trackball, you can move the picture around. So this is kind of for fine adjustments on the image. Similarly, image rotation, if you select that allows you to digitally rotate the image. So if you want to align something, say these particles, we want them to be vertical instead of horizontal, we can do that. So if you don't want to physically move the sample with stage control, you can use image shift and image rotation. In most cases, you probably don't need to mess with these, but you can. Okay, beneath rotation is beam intensity. Beam intensity controls the diameter of the beam on the sample surface. So I'll zoom in a bit. So the idea behind beam intensity is if you have a small beam intensity, you have a small beam diameter. What this means is that the probe size on your image is quite small. So you end up with higher resolution images, but you get a noisier picture because we generate less signal. So I will decrease the beam intensity, and we see at a low beam intensity value, right, our image becomes quite noisy. But if we slow the scan speed, we can see quite high detail in our reduced scan window, right? Lots of peaks and valleys, lots of bumps in this image. On the opposite end, if we increase the beam intensity, right? So I will increase it. See, we lose noise, right? So the image is less noisy, but we lose resolution because the beam is now a wider diameter. So we get more signal, but we get less resolution. So generally, if you're taking images, you want a low beam intensity. For things like EDS or at lower magnifications, you can use a higher beam intensity. If you're unsure, you can set it right in the middle at a BI of 10. It goes from 0 to 20. So yeah, you can adjust that there. So that is kind of the main beam adjustment settings. There is one more adjustment which is not on this column on the right, and that is the lens alignment for the sample, and it is a third focusing knob along with working distance and stigmators. And the way you would do column alignment is this button right here, right? Manual column centering. So if you select that, it brings up the column centering wizard or the wobbler. This adjusts the sensitivity, but if you go ahead and hit next, what the wobbler does is it varies the working distance back and forth, and the column centering adjusts if the beam is coming in perfectly vertical or not. If the beam is not vertical, if the column is misaligned, what you will see is as the wobbler operates, the image shakes. It basically vibrates back and forth. There's no stretching like the stigmators, but the image is moving as the working distance is varied. And you will see this if you manually adjust the working distance. You see the image moves. So if you see this motion, that means your column is misaligned, the beam is misaligned. So you try to find as best you can, right in the middle. We then will go to the wobbler, right, this button here, hit next, and then like the stigmators, you will move the trackball to try to reduce this vibration and improve image quality. So right now it's shaking left and right, so that means you move the trackball either left or right to fix this. I'm going to go to the left. All right, we see we have kind of halted the left and right, but it's now shaking maybe a little bit up and down. So I'm going to go down. All right, that makes it worse. So now I'll go up. And what you want is something like this. So stationary, no motion, just kind of flashing at you. When you're happy with it, you can hit finish. And then you are done focusing. So the focusing steps for the SEM are: you turn the beam on with high voltage. You then do the auto gun heating in the adjustment setting at the bottom right here, auto gun heating. And then you will move to wherever you want to view, set your magnification, and then you do a cycle of adjusting the working distance, the stigmators, and the column alignment, or the column centering. Every time you adjust one of these three settings, it will affect the others slightly. So you do have to kind of do a cycle of focusing. But once you're happy with it, you then move on to a higher magnification and kind of repeat this process. Once you have got the focus you desire, so I'll zoom out, we'll find another spot. Let's go over here. All right, so I'll adjust the working distance. So you see a little bit of stretching. So you can adjust the stigmators. Okay, I'll go back and adjust the working distance. I can look at the column centering. Looks okay. And then finally, these guys are quite small, so I'm going to lower my beam intensity to give me a little bit better resolution. And with that, we can see particles. Right? So once you're happy with all your settings, we then need to take our image. So to take an image, the image capture button is right beneath the column centering button on the right here, acquire image. But before we do that, we want to set up the image acquisition conditions. So on the info bar on the top here, we select SEM, image parameters, and then that brings up this window. And in this window, you can set all of the settings you would like for your image quality. So you can set the resolution. If you want to turn on averaging of the frames, you can do that. You can also set the scan speed that will be applied when you take your image. And you see anytime you change these settings, it changes the time for acquisition. So if you use a higher scan speed, right, our acquisition time goes up as well. Similarly, there are labels at the bottom of the image. See these guys down here. You can change those labels that will be displayed by selecting them here. So once you are happy with all of your settings, you go ahead and hit apply. And then from then on, every time you hit the image acquisition, it will use those settings. So I'll go ahead and hit acquire image. Once the image is complete, it will bring up a save window, and you can save the image as a TIFF or a .png, depending on what you like. Okay, so then you can then save it to wherever you would like on your desktop or on a folder that you have created. Okay, we then close the image window. And then we can go ahead and move somewhere else. Right, you can go look at a different object. And you can focus and take another picture. One last thing before we take the sample out, I want to show you the different detectors. The detectors are in this box here on the right, sorry, beneath our microscope settings. So we have an SE detector and we have a BSE detector. We can switch between them. The BSE detector is less resolution than the SE detector, but it is able to differentiate between light and heavy elements. So what we end up seeing with this is that this is, I believe, alumina on carbon tape. So with the BSE detector, if we switch to that, we can see that the aluminum oxide samples is heavier than our carbon, right? So the alumina is nice and bright and our carbon is quite a bit darker. You lose some surface resolution images, but heavy elements, you get this contrast due to the different weight of atomic elements. So you can switch between those here on this little drop down here, the SE and the BSE. Okay, once you are finished and ready to take your sample out, we're going to home the stage. So that lowers the stage and centers it, so that the next person can come in and they don't have to worry about hitting the column with their sample. Okay, we then will turn the gun off with HV. We then repeat the venting process again. So we do those 3 vents and then take your sample out. So we will come back once I have removed the samples and closed the door again. See you in a bit. Once you've taken the sample out and closed the chamber back door, we want to leave the SEM at vacuum. So we will pump it back down again. And you go through the entire pumping process. Once the pressure is low enough where the bar turns green again, we can then set the microscope in standby mode and then close the software. So we'll come back when the pump is complete. Once you are at low enough pressure where the pressure bar is green again on the lower right here, you're going to go click standby. You're going to hit yes. And that will turn off the pump and the software, so you can close the window and then log off. After you have signed out, be sure to fill out the logbook, which should be on the microscope right next to it. So you put the date, the time, your name. If there's any problems, list them here. But otherwise, you are free to leave the PC running, and that is it.